I'm Anil Kumar, and here is a test problem on Unit 1 functions. Classify the following as odd function, even function, or neither. Support your choice. So we have two functions here, f of x equals to tan x and g of x equals to minus of absolute x to the power of 5. I'd like you to pause the video, answer these questions, and then you can look into my suggestion. Well, we can solve this or answer this question in two different ways. One is algebraically and the other one is graphically. So let's do algebraic solution first. So if you want to find odd or even function, it's better to find f of minus x first. So what is f of minus x for tan x? It will be tan of minus x. Now tan of minus x, as you know, is minus tan x. So we get minus of tan x, which means minus of f of x. Now since f of minus x is minus of fx, so this function is odd function, correct? So we get odd function for the first one. How about the second one? Okay, let's find g of minus x. So minus x we have to replace with an absolute x as minus x to the power of 5. Now we have minus outside. Minus to the power of 5 will give us minus x to the power of 5. Now absolute value is always positive, correct? So we will get minus x to the power of 5, which is exactly same as g of x, correct? Now since g of minus x is equals to g of x, we get this function as even, right? So we get our answers, and that is, here we have an even function and we have an odd function, right? So that is how algebraically we can get our answer. Graphically, what we can do is we can sketch graph of these functions and then figure it out, right? Odd functions are symmetric about origin, the point, right? They have a rotational symmetry about the origin. So if you draw tan of x, you'll get something like this, correct? Where you have these vertical asymptotes at 90 degrees, correct? And this pattern repeats. And at minus 90, correct? So that is how your tan function is. This is 90 degrees, this is minus 90 degrees. You can clearly see it is symmetric about origin. Now absolute of x to the power of 5. Now x to the power of 5, let me draw first x to the power of 5 and then I do absolute value of this. Since it is negative, x to the power of 5 will be like a cubic function but flatter here, right? Flatter here, correct? Now when I do negative, that means I have to flip it, correct? So it will be kind of like this. I mean, we should do negative later. So first what we will do is we will do absolute of this function. Now when I do absolute of this function, then the negative thing gets flipped upwards. So let me continue with this. That's fine. So when we do absolute, this was, let me write x to the power of 5, okay? Now when I do absolute of x to the power of 5, then the negative parts reflects, right? So this part reflects. So we have this kind of function like this. I mean, kind of like this. Do you see that? So it gets reflected here. Now that is your function as positive, but when we do negative of this, then everything comes downwards. So basically negative means this will also flip here, so we'll have kind of like this here, right? And it's not a very accurate graph, and then kind of like this. As you can see, it has even symmetry, correct? It is symmetric about y-axis. So we have points here which will have the same value. So that is how we can show graphically that the function has even symmetry. I hope that helps. Thank you.